We are the Team 3 and we are going to do the Practica 6. And the objective of this practice is to carry out the T6 treatment process of the 6061 aluminum alloy in the different stage, the solid solution, the quench, and the age. Analyze the microstructural and the hardness change during the various stage. And the materials and equipment that we have to use is 6 specimens cut from the 6061 alloys rod, the material for metallography, and the preparation. For the equipment is the electric oven, the tweezers, the protective equipment for the muffle, and breathnet thermometer, also the beakers.
At the beginning of our practice, we were given a bar of half an inch diameter of aluminum 6061 with a heat treatment that we didn't know. So we cut 6 different pieces of about 1 centimeter of bar, and then we use 2 of those as our supply specimens. We separated from the others, and the 4 remaining we put it in the oven at 530 degrees for about 90 minutes. Then after we got these pieces out, we quenched them in water real quick, and 2 of them went also in the oven for 8 hours at 175 minutes. So we have 3 different specimens. The 2 of supplies, 2 of 530 degrees, and 2 of 175 aging. So for 1 of each, we took the specimen and we made a Brinell harness test to know the Brinell harness, and then the 3 remaining we made backlit for each one. And then we applied metallography as we did many times in the course, and we made the beakers micro hardness test, and then we chemically attack the specimens to make the metallography test and know the grain size of each one.
The applications of the treatment of artificial aging are mostly used in the industry and are widely used for the straightening of aluminum, nickel, and stainless steel. Also, the hardening of valves, valve gates, and engine parts, and at last, the straightening of turbine blades and fasteners. The group of aluminum that are susceptible for the hardening of the artificial aging are the growth alloys, and exclusively the 2, 6, and 7 series, which are the 2 is copper, the 6 is magnesium, and the 7 is zinc.
The basic conditions that an alloy system must satisfy in order to be hardened by precipitation are the approximate maximum solubility curve that reduces quickly with temperature, and finally that the composition of the alloy must be less than the maximum solubility. Well, some of the basic mechanisms of hardening in aluminum alloys could be work hardening, solid solution, fine grain, age hardening, and as we already saw, it can be natural age or artificial age hardening, quenching, thermal softening, and finally annealing.
Are important for the practice that we made in the laboratory, such as precipitation hardness, that is a heat treatment in which the particles of the material are dispersed uniformly along its grain structure, that it's accomplished by the use of a solution treatment at high temperatures followed by a rapid cooling. There's also aging, that it's when a material changes its properties due to the presence of a chemical agent that affects its structure or different properties. There's also consistent precipitate, that it's when the precipitate has compatibility with the crystalline structure of the matrix. Solubilization and temper. Well, solubilization is the first step of precipitation hardness and consists in getting to a higher temperature than the solvus line and holding the temperature there. Then there's temper that it's also heating, but below the AC1 line of the material, in order to and then followed by rapid cooling to eliminate the stresses. Natural aging is aging that happens at room temperature. Artificial aging, it's aging that it's heated to a certain temperature to make the process quicker and get different properties than the ones you will get at natural aging. And there's also overaging, that it's aging for a longer period of time than required, and it possibly will end up in the loss of strength or hardenability.
After we finish our practice, we find that the T1 treatment is adequate because after seeing the theoretical process, we find that our process is less than 5% of error. The T1 and the T4 of the 6061 aluminum, they share a lot of properties and many physical properties, but the development different mechanical are different, so the results all change, but stay like less than 1% of difference. So we can define that the natural age is easily for the aluminum 6061. The T6 treatment, it's also adequate because we find that the theoretical has 180 degrees and an average of time for 9 to 10 hours, and in our practice we realize a temperature of 175 and for 8 hours. The probable treatment to which the material in the state of supply has been subjected is the T1.
In this practice, I learned the different aluminum heat treatments for different aluminum alloys. Now I know what the T at the end of the name 661 means. It means the different heat treatment it has been passed or whatsoever. And I mean, this practice helped me a lot to understand more the aluminum treatments, because they are, even though it's metals, are different. They behave differently from ferrous metals. So it's important to know the two different heat treatments for each of them.
This practice showed me that when it comes to heat treatments and types of aging and hardening, aluminum alloys behave differently from steel. In previous practices, we only worked making heat treatments with steel and its alloys, and well, it's quite similar, although in certain things it's really different, and how the aluminum behaves after the heat treatments.
Well, my conclusion to this practice is that even though we use aluminum, for example, in everyday applications, the aluminums that we use have different properties that vary a lot due to the heat treatments. So if you want a specific property or a specific heat treatment, you must need how to accomplish that depending on the heat treatments that the material has. Also, if you receive something and you want to use it in your application, you must know what happened before the material got there, what heat treatments went down, because it may fail before you want to, or it may last depending on the heat treatment, if it was correct applied, or it was correct for the application you wanted.
In conclusion, conclusion for this practice, I learned the different heat treatments for the aluminum, and I think this is very important because we have to know all the difference between the treatments, and in a future know which one to apply for any process, job, or work.